Okay, I was struggling with technology, so basically, I did these in the last thing, but whatever. Okay. So you already said the answers, but whatever. So what I want you to do is determine if these tables are inverse, direct, or neither, and explain why. Pause the video, do it. Yeah, I don't remember what was in the other video. So whatever, we're just gonna pick back up. So this one should be direct, inverse, neither. I hope you know why. Direct, we need to divide y and x. We get 40 every time, so that's why it's direct. This one, we multiply x and y, we get 8 every time. That's why it's inverse. Okay, so then they give us, suppose x and y varies inversely, and they tell us what x and y is. So here is our general form of an inverse function. So since they give us x and y, I can either plug that in to find the constant of variation, or I could just multiply those because we know that's what happens. So if we multiply 12 and 4, that's 48. So that's our constant of variation, so y equals 48 over x. So just like before from the pizza example, we had quadrant 1 only, but this time we now have quadrant 3. With the pizza example, it doesn't make sense to have negative people or negative slices, so that's why it's only quadrant 1, but technically I could plug in negative. So like if I plug in -1 for x, that would give me -48. If I plug in -2, that'd give me -24, and so on. So we do have quadrant 1 and 3 for inverse variation. Just kind of reciprocals of each other in a way. So you should try this next one. So you should pause the video, you try to find the function, the graph, just a sketch, and then what is y when x is 2. So you should pause, but I'll do it now. So we know it's inverse, so I need to find constant of variation. So 8 times -7 is -56. So y equals -56 over x, using the general form. For the graph, this time it's a little different. If I were to plug in 1, I would get -56. So this graph is basically flipped, and you can even think transformations, flipped over the x-axis, so that would go here, that would go there. And what is y when x is 2? So simply, if x is 2, well then y is -28. So just kind of a simple example there. Okay, last thing is just a combination of things. Yeah. So let's first do the story problem. So your math class has decided to pick up a litter each weekend in a local park. Each week there's approximately the same amount of litter. The table shows the number of students who worked each of the first 4 weeks of the project and the time needed for the pickup. So what we're going to do is find a function, and then I'll give you some random questions. So first things first, function. So if we were to look at things, if I multiply these all together, this should be 21.25 technically, but if I multiply all these together, we're going to get 255. So that's constant variation, inverse function. Where x is the number of people and y is the time it took to complete. Let's see. What does the 255 represent? I want you to think about that. What it represents is the total time with one person. Next question is, how many students are needed so that each student works at most 30 minutes? Well, what we could do is plug in 30 for y, and we're going to try to find how many students we would need. So if I multiply over the x, divide by 30, we get 8.5. So we need approximately 9 students in order for each of them to work only 30 minutes. Okay, so there's just a story problem for you. Okay, last thing, combined variation and joint variation. Combined variation, when one quantity varies with respect to 2 or more quantities. And then joint variation is direct variation with 2 or more quantities. Okay, so basically what these are meaning is just, yeah, we have multiple variations going on. So I'll give you an example. So Z varies jointly with X and Y and inversely with W. So like this whole thing is combined variation because we have 2 or more quantities going on and there's variation going on between them. Joint means direct variation with 2 or more quantities. So when you see joint, you should think direct. So let's just go down here a little bit. Not much room, sorry. So Z varies jointly with X and Y. So that means direct variation. So Z equals XY with our constant of variation. So this is representing the direct variation that's happening between Z, X, and Y. But it also says Z varies inversely with W. So if it's inverse, that would be K over W. So this whole thing is the combined variation using joint and inverse. So this would be the answer if it was asking for a function. I do need the K in there because we need to know, like, there is a constant of variation. Okay, last problem. The number of bags of grass seed N needed to reseed a yard varies directly with the area A to be seeded and inversely with the weight W of a bag of seed. If it takes 2 3-pound bags to seed an area of 3,600 feet squared, how many 3-pound bags will seed 9,000 feet squared? So let's make a function. So it tells us that the grass seed varies directly with the area and inversely with the weight. So here was my direct idea, here's my inverse idea. But we need to actually solve things this time. So that tells us we need the constant of variation. So it tells me that it takes 2 3-pound bags to seed an area of 3,600 feet. So if it takes 2 3-pound, so I need to know what all these variables mean basically. So A is area. Okay, so it's telling me 3,600 is our area. Let's see. N is the grass seed and W is the weight. So we have 3 for the weight and we're using 2 bags. So that would be how we substitute everything in. Basically, I need to know what all the variables mean, then the things that they give me and how those fit in. So if we solve for K, so if I bring over the 3, divide by 3,600, we get 1 over 600 for K. So back to then the original, I'll just substitute in K and now answer the question. So we want to know how many 3-pound bags will seed 9,000 feet. So I'm trying to find N for 9,000, still a 3-pound bag. And we get 5. So we need 5 bags. Woo! That's it for 8.1. Tomorrow we will do some practice for it, and yeah, we'll see what that looks like with our online class. But I need you to submit on Sycamore's Dropbox the notes that you took as you watched this video so that I know you watched the lesson. Thank you. See you guys tomorrow.